Today I'll be speaking about sampling techniques. Now the sampling techniques will be very useful for the researchers, particularly the researchers, all the PGs, because thesis is very compulsory for them to finish their PG. So before doing any study, let it be short term or thesis or anything, sampling technique plays a very major role in doing a proper study with proper protocol. So that time sampling technique is very useful for them. Not only for them, for all the academicians, academic staffs who are interested in doing research. And then last but not the least, all the dental graduates, because sampling technique is one of the important questions which will be asked in every exam. So these are the contents I'm going to speak in sampling. First, I'll tell you about introduction, types of sampling. In that, there are two types. One is probability sampling, another one is non-probability sampling. In probability sampling, there's simple random sampling, systematic random sampling, stratified random sampling, cluster random sampling, multiphase and multistate. Non-probability sampling, it is quota sampling, purposive sampling, convenience sampling, snowballing sampling, sampling bias and advantage of sampling, conclusion and reference. Introduction. In introduction, you should know clearly about these three terms. First is universe. Second is what is a sample. Third is a sampling frame. So I'll give you an example. First, this is a universe. From the universe, a sample will be obtained. A sample. And from a sample, a sampling frame will be obtained. So how it will come is, this will be a perfect diagram for it. So this is a universe. This comes a sample. And this is a sampling frame. For example, I do a study in hospital-based study. Okay. So my hospital-based hospital, all the hospitals will be my universe. So from that, I particularly select Chennai hospitals. So they will be my sample. And from Chennai hospital, I particularly select SRM hospital. They will be my sampling frame. Okay, are you clear? This will be a continuous step. First, you have to select a universe, then goes the population, and then goes the sampling frame. So, without this process, you can't go into the sampling technique. Now, let us move in classification of sampling. So, I told you probability sampling and non-probability sampling. So, probability sampling is nothing but all the members of the sample are a representative, whereas non-probability sampling is all the members are not a representative, are not a representative of whole population. Okay, so this is a main difference between probability and non-probability sampling. In probability sampling, there are 6 types: simple random sampling, systematic random sampling, stratified random sampling, cluster random sampling, multi-stage and multiphase. Whereas in non-probability sampling, judgmental or purposive sampling, quota sampling, convenience sampling, and snowball sampling. Now let us move on to the next slide, and I'll tell you in detail about what are the different types of probability sampling, its merits and demerits. In non-probability, I'll tell you on what is judgmental, quota, convenience, snowball sampling. Types of sampling technique. First, moving on to probability sampling. Probability sampling, simple random sampling, systematic random sampling, stratified random sampling, cluster, multiphase, and multistate. First, I'll tell you what is simple random sampling. Simple random sampling is nothing but, for example, you take a group of people, okay, group of people. That group of people you select randomly, 1, 2, 3, 4, 5. Randomly, if you select, this is called simple random sampling. In the simple random sampling, there are two types: lottery method, table of allowance. In lottery method, you put like a lottery sheet, like we play Raja Rani like this now. You put a lottery sheet of 1 to 10, and in that randomly in the lottery method, whatever it comes to select, this is called lottery method. Table of allowances, you put a table of 3 into 3 table, and in that randomly if you select, these are called table of allowance method. Table of allowance method. So other such examples is, for example, you take a class standard 4 attendance order. In that they are Lalita, Lavanya, Dana, Nazia, and all these 2, 3. These are all the names. You randomly select, means this is simple random sampling. Okay. Next, moving on to what are the merits of simple random sampling and what are the demerits of simple random. Simple random sampling is the earliest method and commonly used because it's very easy to select randomly. So this is very easiest method and commonly used. Not any additional information is not required. For example, I told standard 4 name list I take and I select the population. Okay, I don't need about the gender difference or don't need in age or nothing. I need no information. It only standard 4 name list is enough. So there is no additional such as gender, geographical area, from where they came, from India or whatever state or district. Nothing I need about them. Other than complete list of members. As I told, I need the name list, right? So complete list of, along with the contact information. Analysis of data is reasonably easy. Yeah, analyzing a name list is definitely easiest form. But disadvantages, not make no use of auxiliary information. For example, you don't need any additional information rather than the name list for this type. Can be expensive and unfeasible for large population. For example, you are going to do survey in India. So that time, how can you obtain a full database? You can obtain a full database of name list, but obtaining from them is difficult task. So it's one of the major demerits. Not to be representative of whole, obviously they can't be a representative of whole population. I randomly choose them without any information. So that time they are not a representative of a whole population. Next, moving on to systematic sampling. So in systematic sampling, here you can see systematic sampling, you first allocate 9 individuals. In that, you randomly select the nth number. For example, if I take 3 as my nth number, so I randomly select the 3rd individual. Got my point? So this is the nth number. So systematic sampling, you select the nth number. This is very simple type of sampling. The major merits and demerits for this type is no mistakes can be obtained now because it's a nth number, so no mistakes can be obtained. More precise than simple random sampling. Yeah, at least here you select an nth number, but there it's not precise, but here it is less precise because it comes as an nth number. More evenly spread. Yeah, obviously. Demerits is if list has periodic arrangement, then sample collected may not be accurate. Yeah, if they are periodically collected, if they are periodically arranged, for example, if I arrange under age distribution 5 years, 10 years, 15 years, 20 years, and I arrange them like this. For example, so 16 are there, right? So if I take the third number, for example, these are my third number. So all I take is 15 age group only. So they are not a accurate representation of the entire population. Now, stratified random sampling is a easy type. Nothing more. Stratified random sampling is you divide into stratum. So this is one stratum. This is another stratum. And this is another stratum. From each stratum, you select randomly. You select randomly. So this is stratified random sampling. I'll give you another example. For example, standard 4, there are 3 sections. Section 1, section 2, and section 3. In each section, you randomly select 20 individuals means this is for stratified. Each section becomes a stratum. Okay? Advantage, there is merits of this is control of sample size in this data can be done. Yeah, see, if there are 3 stratums, I can control taking 20 each. I have the control. And next is increase statistical efficiency. Yeah, because my sample size in each stratum is equal, statistical efficiency will be more. Provides data to represent and analyze the subgroups, enables use of different methods in data. Okay, the demerits are increased error if subgroups are selected at different rates. Yeah, for example, now I select a school. In that I select standard 1, standard 6, and standard 12. These are my different stratas, and from them randomly I select 20 people, 20 people, and 20 people. Now what happens? The subgroups are of different rates. Standard is nearly 6 years old, for example. This is nearly 12 years old, for example, and this is nearly 17 years old, for example. So when they are different rates, so this might be an important email. High cost, because when the stratum are differentiated, this is 3 stratum is okay. When you different into a numerous stratums, you might need a high cost effective cost, money should be needed. Next is especially expensive if stratum of population may be created. Yeah, if I create a special stratum on population, then the procedure might be costly. Cluster random sampling is very easy, ma'am. For same example, ma'am. Standard 4, section 1, 2, and 3. From these are my strata, as I told you before. But in cluster random sampling, what I'll do is I'll take the whole strata as one cluster. Got my point? But in stratified random sampling, I don't take whole stratum. I take individuals from each stratum. But in cluster random sampling, I take this as a whole cluster. So only one cluster I select. Here is a typical example. Avenue 1, Avenue 2, Avenue 3. The people from Avenue 1 fully as a whole, if you take, then this is called cluster sampling. Then from Avenue 3 whole, if you take, then this is called cluster. This is called as a cluster you take. You don't pick from stratum. Okay. This is a reduced field cost. Yeah. If I take as a whole number, my efficiency, that is picking is easy for me. Easy with less field cost. Decreased field cost. Applicable when no complete list of units is available. Yeah, obviously, when I don't have a complete unit, then this procedure will be helpful for me. Demerits are clusters may not be a representative of whole population. Yeah, obviously, Avenue 1, Avenue 2, Avenue 3 with so many age groups and so many geographical areas, they might not be a representative. Analysis is more complicated than stratified random sampling. The analysis is a little complicated. Here you select the stratum, you select randomly, but when you select a cluster, you need some analysis. Next, difference between stratified and cluster. As I told you before, population are divided into few subgroups. Here, many subgroups. Homogeneity within the subgroups is very necessary, but in cluster, heterogeneity within the subgroups is seen. Whereas heterogeneity between subgroups within the subgroup is different. Between the subgroups is seen. Homogeneity between the subgroups is seen. Here, choice of elements from within each subgroup, but here no. Here, random choice of subgroups are given. Got it here? From there, you select like this any three, but there it's not like that. You select the whole population. Now, this is a typical example, ma. This is stratified and this is cluster. Now, this is called a stratum. So in stratum, you randomly select from each cluster, from each stratum. Okay, but in cluster is as a whole you choose. As a whole you choose. You choose as a whole cluster. Next. Now next moving on to multi-state sampling. In multi-state sampling, you divide into stages. From state, you select district. From district, you select villages. From villages, you select the household. From household also, you can select it as low socioeconomic, high socioeconomic, middle socioeconomic. It's R Vishma, socioeconomic status. So like that you can say. This is called multi-state sampling. This will be done in survey systems. When a survey in India is done, from India, you select some districts. From districts, you select some villages. From villages, you select some households. Got my point? Merits is no complete list of population is required. More feasible approach for large population is required. Yeah, complete list. You don't need a complete list of name list or something list is not required. Your more feasibility approach for large population. Yeah, it is most feasible approach for large population. Large population means example survey. Demerits are several sampling units are included. Yeah, obviously villages, districts, states, all these are like sampling units. Sampling error is difficult to measure. When there is an error, it is very difficult to measure. But no choice for a survey. This method is very applicable. Is very applicable. Got my point. Next, let us move on to multiphase sampling. In multiphase sampling, it will move on in phases. Okay, I'll tell you an example. For example, you go to a school. You examine 1,000 students. This 1,000 students, almost 800 students have oral problems. In that 800 students, 400 students needs treatment, and in 400 students, 200 students definitely needs follow-up. So how it goes? It goes like phase of treatments. From 1,000 you select 800. From 800 you select 400. From 400 you select 200. So it moves on like a phase. So you call it as multiphase sampling. Okay. Next, moving on to its merits and demerits. This may be adoptive when the interest is in any specific disease. For example, dental caries or oral health or tuberculosis or leprosy, any specific disease, okay? That time this might be useful. Less costly, less laborious, more purposive. Whereas demerits, it's not applicable if your findings are not of specific disease of interest. In future slide, what I told you, oral health problems. But that test might be effective from any specific disease. Okay? Now next, moving on to non-probability sampling. What I told, non-probability sampling, it is not a representative of whole population. So, 4 types: judgmental sampling, quota sampling, convenience sampling, and snowball sampling. Judgmental sampling also known as purposive sampling. Okay? In non-probability sampling, first moving on to judgmental sampling. So, judgmental sampling is nothing but I judge the people accordingly. For example, I do a study, a gap study on students to examine their academic performance. What of academic performance? Okay, performance by an app. So what I do, I need effective results, effective in the app. Results should be effective in the app. So I take bright students so that the academic performance will be very good. Very good. So judgmental, I judge the individuals and take it to account. Whereas quota sampling, as we all know, there is a quota for our final year BDS. Endo, we have class 1 filling, 20, class 2 filling, 10, and a composite filling, 20, like that. In surgery, we have quota like extractions, we have to do simple extractions, 20, and complex extractions, 10. We have quota, right? So that goes in quota sampling. For example, my quota is male above 50 means I select this as my quota and select the samples. Okay? Convenience sampling is very easy sampling. This sampling, non-probability sampling, this is the commonly used sampling technique where according to my conveniency, what? According to my conveniency, I select the samples. For example, I do a study, gap study among the undergraduate students, and I distribute according to my conveniency among the students who are available right now, who are available at that particular time. So according to my conveniency, I select the sample. Now next, moving on to snowball sampling. So snowball sampling is nothing but, for example, you do your study on oral cancer patients. That particularly you do on smokers. So what you do is you identify a single smoker, and from that smoker you tell him that please refer your other friends who smoke. So they refer 2 smokers, and from that 2 smokers you get 6 smokers. From that 6 smokers you get 12 smokers. From that 12 smokers you develop. So from a single this you develop so many. You form a cluster. You form a big cluster. So this is not snowballing sampling. Snowballing is you roll a dice and make everybody fall into your sample frame. Okay? This is called snowballing sampling, or as I told you before, chain reference. So I tell them to refer. So the chain goes on by referring one another. So now next moving on to advantages of sampling. The first advantages is that cost of the investigation will be reduced. For example, you do a survey in India. You can't take whole lot of India. That time what happens, your cost will get increased. So this will help you to reduce the cost. Second is a thorough investigation. It allows us to know the thorough investigations of units of samples. Third is a sample can be covered more adequately and in more depth. More depth and adequate info can be obtained by sampling technique. Okay. So next moving on to errors in sampling. First is the observed error, second is instrumental error, third is sampling error. Observed error is of two types: subjective error, second is objective error. Now what is subjective error is nothing but when you do a faulty interrogation in the individuals. What do? You ask a questions and give 4 options. You tempt them and give them a hint that this is the correct option. So that then comes under subjective error. Objective error is I don't know, do not know to record BP. But what I do, I record the BP. So what happens? Faulty records gets obtained. So this comes the objective error. Instrumental error is a BP up at this sphygmomanometer is not working. A record in that is not properly working. So that comes under instrumental error. Next is sampling error is we have to not choose small samples. Non-probability error, non-probability sampling is a error only. So biased samples should not be selected by the researcher. Okay. Next is last but not the least, a conclusion of sampling technique is I have discussed in detail about all the sampling errors, merits, demerits of all probability and non-probability sampling. But you know, this sampling technique will overall help all the researchers, all the PGs, all the students who are doing research for a perfect protocol to be followed in a study. When you don't obtain a sample technique, no, when you don't seek a help of a sample technique, what you do, you don't get into a localized population. That is, you have to get a specific population when you do randomization. If you don't do randomization properly, then you will go to non-probability sampling where the results can't be applied to a generalized population. So sampling is very essential for an individual, for a researcher to obtain results generalizedly. Okay. So these are my references in which I thank each and everybody who is listening my lecture patiently, and I honestly thank Dr. Sri Sir, MDS CONQUER, who gave me such an opportunity to address you all and fetch some knowledge about sampling techniques. Thank you each and everyone. Thank you.